So I have some new visitors today. I have like family of deer lives on my driveway. They're there every morning and night. Skunks in my front yard and the groundhogs and foxes have taken over my backyard. And now I have a family of kittens or cats. I don't know if they're family. I'm sure they are. They're like there together. So maybe somebody can tell me what kind of cats they are. I've never had pet cats. Give them a bowl of salmon. Anyway, let's get to work. Calculate the volume of a warehouse. Volume. Calculate that. Length times length times length will give us volume. That's all we got to do. So let's take out our calculators and do 22.4 times 11.3 times 5.3. I better do that again. 22.4 times 11.3 times 5.3. Yeah, that's a big, ugly number. Okay, 1,341.536. This is not a measurement. This is a calculation, and when we calculate using based off of measurements, we have to follow these sig fig rules. So that measurement has 3 significant figures. That has 3, and that one has 2. When we're multiplying or dividing, like we are here, we're multiplying. Your answer has to have the same number of sig figs as the measurement with the least. All right, so 3, 3, 2. All right, this is the limiting measurement you could say. All right, so our answer has to have 2 significant figures. All right, from left to right. The 1 and the 3 are the only digits we keep. Now we peek one more to see if our last digit rounds up or stays the same, and it's going to stay the same. So it's 1,300. Meters times meters times meters is meters cubed. Now I don't ever, I always like writing these kind of numbers in scientific notation because you never know if that was measured or if that was measured. The rules say it wasn't, but it could have been, right? Only Jack and Jill know, right? Or whoever measured it. So let's rewrite this in scientific notation. The implied decimal is there. All right, we need to move it to a place where the coefficient turns into a number between 1 and 10, or greater than or equal to 1 and less than 10. 1, 2, 3. There we go. 1.3 is greater than 1 and less than 10. Now these zeros, you know whether they're significant or not, and we know they're not, so we're not going to write them. If they were measured, you could write them, and everybody would know that they were measured. But we didn't, because we know this measurement limited us to 2 sig figs. How many times we move the decimal? We moved it 3 times. That's like multiplying this 1.3 by 10 3 times. All right, so we still have the equivalent value.